Dr. Maria Pia Casarini is currently the Vice President of the Polar Educators International. She actually has just gotten back from Iceland and has a couple of her colleagues on the Zoom with us. This is a group of teachers from all over the world that specialize in polar education. She's got degrees from Milan Cattolica University and Cambridge University, and she's researched polar history at the Scott Polar Research Institute. She's made 10 trips to the Earth's 2 poles, 8 to the Arctic and 2 to the Antarctic. She participated in the Winter Weddell Sea Project, which was the very first wintering scientific program of a ship in the Antarctic. She's lectured on ships and at the Genoa Polar Summer School, and she served as director of the Zavadi Polar Institute in Italy. She has contributed to the last 2 COP. I think you've also been to at least one IPCC, if not many, and you did a special session at COP26 that I will link into the chat so that people get a chance to see this. And she's very inspirational. I'm very blessed, we all are, to be able to listen to her today. So thank you so much, Maria Pia, for being here for us.
Thank you. Thank you. It's such a pleasure to address you. And we all believe that Earth's Day and Earth's Week is absolutely necessary for everybody. So that's something that we certainly need to know about. Now try. Okay, so let's talk about both poles. I must say that although Antarctica is very big and studied quite a lot, I will concentrate more on the Arctic and I'll explain why. So let's start with the Antarctic first. As you see, the difference between the Arctic and the Antarctic is quite marked. The Arctic is like a Mediterranean Ocean surrounded by land, the circumpolar nations. Antarctica is a continent surrounded by sea. And it's not just sea, it's actually the wildest ocean in the world, because as you can see, there is no land to stop the circulation of the Southern Ocean. And that, Drake Passage, very famous, and the roaring 40s, the 50s and the 60s are very famous as very strong seas. Now, what happens to the ice when we go to Antarctica? Now, what we see, I was very, very fortunate to be on the Winter Weddell Sea project in Antarctica. In fact, we were on the Weddell Sea, that's this area here. It's kind of difficult to consider Antarctica because you have to think in terms of the other parts of the world, because it's right at the pole. So this is South America, this is Africa, and this is Australia. So depending on where you are, you have a different version and vision of what Antarctica looks like. Since we are European, we tend to look at it this way because Europe is just in this direction. So this is what we did with the Winter Weddell Sea project. I actually was on board as a non-scientist to write a book about the expedition, which came out as Unternehmen Polarstern. And what we saw was actually very interesting because it was the first ship to go in the Antarctic winter since Shackleton's ship, the Endurance, the ship that has just been found again by a group of explorers. So what we saw really was firsthand what's happening to the ice in the Antarctic. So the ice starts forming very, very gently with fragile ice, then dark nihilus, and then, sorry, I can move this one over. Yes, I can, excellent. And then that was the surprise we got, was this early stage of pancake ice, because as you see, very tiny, round pieces of ice, which nobody really expected. And that's quite understandable because as you see the motion of the waves. because the sea is so wild, the ice can't grow calmly like it does in the Arctic. And then because of the ice motion, pancakes go on top of each other. And then eventually, when you get more into the ice, they begin to form a wide area. And then they consolidate. Of course, here we were getting more towards the continent, of course. And then and this is what the ice looks like around Antarctica in the end. And of course, the Antarctic winter starts in June and it ends in October, September, October, and then there is the spring bloom, which is exactly the opposite of what happens in the Arctic. I just put in this image, which I absolutely love. This is when you have a core of ice and you cut a very thin slice and then look at it with cross-polarized lenses. And you can see, this tells you a whole story. It tells you that ice would actually be quite happy to grow crystals like you see at the bottom, as a columnar shape. But look at the mess up here. That was actually caused by the movement of the ocean. So the ice just wasn't left alone. So by banging the various pieces, this is the image that comes out. Now, the problem, just yesterday, I got a hold of a paper that came out in the journal called Advances in Atmospheric Sciences. And it tells us that the Antarctic sea ice on February 25th, 2022, reached a record minimum in extent for the second time in 5 years. The first time was in 2017. And since the launch of the first satellites in 1978, this is the first time that the ice extent has been under 2 million square kilometers. Notice that the average data between 1981 and 2010, that is to say 30 years, the ice extent is now about 30% lower. So the idea that we had for quite a while that in fact the ice around Antarctica was growing doesn't seem to be bearing any truth and reality now, because we have these absolutely up-to-date data. What worries most, in fact, is not just the sea ice, because the sea ice then melts completely. So it's really first-year ice, apart from a few areas like the Weddell Sea here, or the Ross Sea at the bottom on the other side. But what worries people are the glaciers, which some of them are actually quite unstable. It's famous already, the Larsen B, south of the Weddell Sea. There was a huge iceberg that came out, I think it was about like 50 square kilometers, something absolutely huge. And they followed the currents and then they spread out in smaller pieces and then they melt in the warmer ocean once you come out of the Antarctic. But the problem is that while sea ice is already growing on the sea, and therefore it makes absolutely no difference to sea level rise. It's what I call the ice cube in the gin and tonic. You put the ice cube, but it stays as it is. If land ice gets into the sea, then it brings to sea level rise. And now there is the Thwaites Glacier, which is really object of very, very careful study. You see like a tabular iceberg of this size that comes from the glaciers on the continent. This will increase the sea level in the world. And the Thwaites Glacier is really in a dangerous position, and there are many, many studies about it. So I would leave Antarctica now because I really want to get down to the Arctic. And I can tell you why. It's because the Arctic has a lot of population. There's a lot of human beings. In Antarctica, there's the scientists, and there's quite a lot of scientists. But They're not natives, while of course the Arctic has had native people for a very, very, very long time. Now, this gives you a little snapshot of the past, when you could see that in winter here on the right, the sea ice really covered and linked more or less the entire Arctic, from Siberia to Alaska, to Canada, to Greenland, and coming even down towards Newfoundland and eastern Canada. In the summer, a lot of the ice would melt, but there was still quite a sizable area which wouldn't melt in the center with the North Pole. Now, what happened in the past, the fact that this ice wouldn't melt, it meant that every year ice was added to the previous year. And this brought what was called multi-year ice. Here in summer in the Baltic Sea, this is in the 1970s. Let's see if I can move myself a bit. In the 1970s. And look how big it is compared to the humans over there. Now, this ice practically doesn't exist anymore. This is first year ice that forms just for one season. And the Arctic now is becoming quite a lot. A great percentage, about 70%, is now first year ice. In 2012, we had a summer minimum. Look how tiny part the ice is. All this was open sea. And of course, there was a year when 3 ships, not icebreakers, managed to reach the North Pole together. That was quite remarkable. And there was a previous record alone in 2007, but basically the ice is melted. And we can see why, and everybody's familiar with the albedo effect. Now, if you got white, the incoming radiation gets reflected back. If there isn't white, the incoming radiation gets absorbed. So if you have open sea, the open sea is quite dark, absorbs the heat. The ocean gets warmer, it melts more ice. It's a vicious circle that starts, and this is exactly what's happening in the Arctic. The problem about melting is, again, glaciers and mainly the Greenland ice cap. Surprisingly enough, the IPCC reports have always underestimated, maybe willingly, or we think it is actually willingly, the global sea level rise in the future. And because it is, it's seen that ice is melting and is going into the sea, and the sea is going up. And also with the heat, the ocean expands as well. So that's quite a dangerous thing, so above all because most of the most important cities in the world actually are coastal cities. Think of Shanghai, and then areas like Bangladesh, and even Italy, or the part of the Adriatic Sea is quite in a dangerous position. I love this quote, and that's one of the reasons why I want to concentrate on the Arctic. It was actually came from the NATO Parliamentary Assembly. What happens in the Arctic, it does not stay in the Arctic. There are global consequences that cannot be ignored. And I just keep this mantra all the time. What happens in the Arctic does not stay in the Arctic. And I'll show you very, I will touch a few points in which this actually is very true. Permafrost. Permafrost melts. At COP26, I was very lucky to be invited for the 2 weeks. There were groups of young people coming from the Arctic, living in the Arctic, who were actually in tears, saying, our land, our houses, our villages are being destroyed by permafrost. And that's actually very, very dangerous. So what have we done to our planet? This is the question. We can go back with coring, especially in the Antarctic and also in Greenland. We go back about 800,000 years. Now we know from analyzing the air bubbles and the gases, etc., that CO2 has always existed, but the Earth, even moving in between ice ages, has had a preferred area of presence of CO2, with a maximum of about 280 and a minimum of about 180, 160. Now, if we see the various ice ages, the last ones that we could actually analyze, you see that we were actually going towards another ice age. In fact, in the 1700s, there was the Little Ice Age. Then something happened, and what was that? We started burning fossil fuel. And burning fossil fuel, this CO2 in the atmosphere grew absolutely to a level that has never been seen in the last 800,000 years. Now, with CO2 comes warming. With warming comes the melting of sea ice. And you see, even in 220, how lower the sea ice is, not just in the summer, but throughout the year. And this is, it's called, it's called the death spiral, Arctic death spiral. That is to say, each color is 1 month of the year. Now, if, and each year is here. Now, if the ice had remained the same, we would have absolutely concentric colors here. But instead, look how, with the moving of the year, how closer to zero the ice is becoming. And the black is September. September is usually the month of least ice because of the heat of the summer. And we can see also an important point is not just the sea ice extent, but the sea ice thickness, as I told you about, the fact that multi-year ice has been practically disappearing. Look how the volume of sea ice has gone down, absolutely frighteningly so. In fact, most of the ice is now first-year ice. Now, how did we study this? The best was going on submarines. And my husband has done 6 trips on submarines of the Royal Navy under the ice, under the North Pole. And this is, I owe him and the Royal Navy these images of the submarine coming up at the North Pole. This is how the scientists are supposed to sleep, not very hospitably. And this was the first submarine results, which I had to analyze back in the 1976 was the voyage, and we analyzed these rolls. This was just one dimension. And we could see how the pressure ridge, that is to say, when 2 pieces of ice collide, then on top you have a certain mound and a lot more underneath in the ice. The way of measuring became much more sophisticated, and in 2007 there was a multi-beam sonar actually mounted on top of the submarine that could give an amazing colored image of the underside of the ice. So that was a real improvement. Then there was an accident on board, an explosion, 2 sailors died, and the Royal Navy was sending more submarines to the Arctic. So I'd like to follow a bit how we studied CO2. And if you think 1896, there was a Swedish scientist, Professor Svante Arrhenius, who for the first time linked the presence of CO2 with the burning of fossil fuels. An interesting point is that this Svante Arrhenius actually is a great uncle of Greta Thunberg. And in fact, Greta's father is called Svante after this relative of the family. So in the 1950s, 1958, an observatory was set up on this volcano in Hawaii, Mauna Loa, and really still is the longest record of measurements of CO2. That's how we see how the CO2 has grown in such a fast way. And this is actually as of 2 days ago. We're at 420. But what is interesting is, of course, there is a kind of seasonal movement. Sometimes you get much higher than that. But what is interesting is that year on year, you get at least 2 to 3 parts per million increase every year. And this graph really is absolutely unequivocal about it. What is interesting and kind of frightening, really, this is an interesting point that has been made, that all these writings here are COP1, COP2, COP3, the Rio Summit, the Copenhagen Accord, the Paris Agreement, etc. And there's been absolutely no effect. And this is the frightening thing. CO2 just keeps growing. And we can even see that there's been no movement whatsoever, even during the lockdowns, when nobody was traveling and nobody was doing anything. So, and you can see also how the temperature of the Earth has been growing. Already we are averaging 1.55 degrees C above pre-industrial. So we have already come over one of the aims of the IPCC, which was less than 1.5 degrees. And I'd like to show you something which the current president of Polar Educators International has sent me, which is a knitting pattern that we start from 1880. These are anomalies on a basis from NOAA data, and you go year after year after year until this very strange 1944, and then you go again and you get a bit pink until you get absolutely these last years are completely purple and dark red. So this is my amusing knitting, climatic knitting, but it's quite an impressive way of realizing how the temperature goes up. Very recent, last year in Canada, 47.9 degrees C. In the United Arab Emirates, 51.8 C. These are not temperatures where human beings can survive, basically. And let's see what happens in the Arctic. This is Kanak in northwest Greenland. We're actually part of a European Union program where these sledges had been fitted with the transponders so that, because the ice was already too thin and the doctors could go inside, go under the ice. And this is actually same place. This is what has been last summer. So that's really pretty frightening. Ice camps. This is an Annapolis camp from the University of Washington, Seattle. They used to have planes landing and having this winter field to do research. No way anymore. They can't. The ice is too thin, too dangerous. So now ships get frozen in the ice. And on the ice, you only have the instruments. The individual live on board and then come out. So even, this climate change affecting the Arctic is also changing the way that research is done. Another point that wasn't really considered very much is that also snow on land melts in Siberia and in Alaska, for instance, and it creates darkness. Darkness absorbs heat. So again, we add more heat to our planet. And especially in Siberia, have these fires that, like this one, is frightening. It kept burning even in winter underneath the snow cover. I was driving with my husband in Pasadena. That was a fire. And we had to come out of the freeway. So, as we said, what happens in the Arctic doesn't stay in the Arctic. So now I'd like to very quickly get you through what are the consequences of climate warming. So this one, for instance, is the sea level rise. Now, this was on the Greenland ice cap in a single day. The 1st of August 2019, the air temperature reached 21 degrees. And in a single day, it's 12.5 billion tons. Now, just as I was at the 5th International Group meeting of Polar Educators International, one teacher came up with a very interesting comparison. You can't really think about 12.5 billion tons, but think about elephants. How many elephants would that be? And it's something like 40,000 elephants in one day coming down into the sea. So that's something that is interesting. And also, this was another surprise. Look how black the ice cap is, that one expects to be all white and pristine. This is the result of the fires of California that Sarah was a victim of for a long time. And this is, again, is dark, therefore absorbs more heat, and more ice from the ice cap actually melts. And it creates rivers. These rivers go into the sea and cause sea level rise. And this is the projection of the rise in sea level. We're still about 1 centimeter or less than 1 centimeter, but it's going, that's the trend. Now, the next thing is a huge methane release. The methane is another very dangerous, powerful greenhouse gas. It has one advantage, that it doesn't stay in the atmosphere as long as CO2. But the main area for where the danger of methane coming up in the atmosphere is here in the very, very low seas north of Siberia, the Eastern Siberian Sea, the Laptev Sea, etc. As you see, the Arctic Ocean is very deep in the center, but very, very narrow or very low on the continental shelf around here. And in fact, these are methane plumes that have been measured. Only Russian scientists can go and measure this. Look, this is only 70 centimeters. This is how low the sea is in that area. And of course, when it was covered with ice, there was no problem. But the ice melts, the water is so shallow that it gets warmed, and the permafrost that had been on the bottom of the sea starts melting, starts warming up. And methane was trapped from the ice ages in the bottom, and it tends to come out now. These are plumes that are seen, and because the sea is so shallow, the plumes just come out into the atmosphere. This is the methane hydrates. This is the form that where they are, that taken down by the permafrost. But if the permafrost starts melting, these methane hydrates come into the atmosphere, and it's called like burning ice. If you put a match, it will catch fire. And these are bubbles coming against the ice. And there was a study made in effect of methane outbreak on global temperature. They immediately think that if there is a 50 gigatons in 10 years, there will be a rise of 0.6 degrees C, whether with a big pulse or not. But anyway, it's a very dangerous gas. And then we have another effect, which is the slowing down of the jet stream. In the past, the jet stream is what makes us go faster when we go from west to east on a plane. Well, this jet stream, because of the warmth and having less ice in the Arctic, it's become weaker and it meanders more. So that, in fact, warm air can go north and cold air can come south. And this is a simulation. And you can see how it can create this weird temperature where in Alaska you can have 20 degrees C, and on the east coast of the United States you go below zero. The problem with this is that the areas affected are the ones where crops are grown, the temperate areas. So with those kinds of temperatures, gradients and changes, also there are problems with crops. There's been a study that if there is a degree of warming, there's less yield out of the most important crops, especially for feeding people in Africa and in Asia. So that's another problem. And the food price index, they actually made a study linking the food price with unrest in Africa, and especially in Africa. So people that live in cities don't eat, and so they riot. So there's also another problem about the ocean acidification, which I'm sure that you in your institute are studying much more than I have done so far. And what can we do? That is the point. The Paris Agreement was arriving at less than 2C. We have seen that reducing burning of fossil fuels doesn't really do much. Taking CO2 out of the atmosphere could be one way. And also something surprising is how much CO2 cows can cause. 60% is livestock, 30% humans. Wild animals are only 4% on this planet that have remained like that. One way could be an experiment called in geoengineering, which is trying to whiten or brighten the marine clouds that are gray using seawater. It's very much at the experimental level, but they're trying to see, because even if there was a problem, it could be just solved. It's not putting chemicals in the atmosphere, just seawater. And direct air capture is what we are thinking might help the planet, just taking CO2 out of the atmosphere. But at the moment, the techniques are very expensive, and we put in the atmosphere 42 gigatons per year. Now, no factory, no plant has managed in any way to take even a minute amount of that. But it's an experimental, and we visited some factories that deal with that direct air capture. And one that seemed very promising is Blue Planet in Los Gatos in California. This is actually a limestone that is completely carbon neutral. This comes from CO2 absorption. That gets worked into little pellets, and then they put it in concrete and use it for construction. So this concrete is actually got 44% limestone that has no CO2. And they turn it into sand. And here is a totally carbon neutral covering at San Francisco airport. They actually used this sand is completely carbon neutral. Another way of trying to take CO2 out of the atmosphere is sequestering it in basalt rock. In fact, I was in Iceland last week, but unfortunately we didn't manage to visit Kleinworks, which is a Swiss company. And what they're doing, using geothermal energy, which is very rich in Iceland, they have actually started in September a much bigger factory called Orca, and for the capture of CO2. And they put it in the basalt rocks underneath the mid-ocean ridge. And it melts, it reacts with this rock, and it shouldn't come out ever again. So that's another point. And then other experiment is converting it to jet fuel in Squamish in British Columbia, Canada. So these could be ways of knowing. Now, all of this is quite well explained in this book that my husband wrote called A Farewell to Ice. And there's a very nice American edition, which is done by Oxford University Press. And I also recommend this really interesting movie. Some of you may already have seen it on Netflix, called Ice on Fire, narrated and financed actually by Leonardo DiCaprio. And that really gives a lot of optimism in the sense of let's try and do something. Now, I'd like just to finish with Polar Educators International, which is this network of educators, not just teachers, but anybody can be an educator, a polar educator. And we really try to match scientists and educators so that the public can understand more and more how research is going. And this was our fifth international conference that we just finished on the 15th of April, which, given the fact that Iceland is very famous for its sagas, we call these stories in ice. And we had a great time. We had to put it off by a year because of the pandemic, but it was a very inspiring conference. And this is us under a basalt rock in the beach of Rayensfield. And just to let you know what, it's not just the Arctic, but also on land, glaciers all over the place, even in Italy, in the Alps are melting. And this Okyoku Glacier in Iceland. These are photographs given by our host, who's the main meteorologist and glaciologist in Iceland, Octo Sigurdsson, 1990, 2003, 2014, and it was extinct in 2019. So what they did was they actually put a commemorative plaque where the glacier was, and it's a letter to the future where they say that here there was a glacier for the future generations, so that you don't forget. And I like to finish again, what happens in the Arctic does not stay in the Arctic. And so we are all victims, and we don't have a planet B. So this Earth is very precious, and this Earth Week, I hope that can give people more ideas on how to take better care of our planet. Thank you very much.